In this video, we are going to talk about the standard forms in Boolean expressions. There are two forms actually. The first one is we call the SOP. Okay, SOP form. What is SOP form? Well, SOP states that the expression is given as sum of products. Okay, the expression is given as sum of products. Okay, so this is what we call the SOP form. So what are some examples for sum of products? Well, let's say the output is given as f is equals to ab plus a bar dot b bar. Okay, here if you look at this closely, okay, here we have two signals given as products. Okay, the signal a and b have been combined using an AND gate. Okay, so we can say a dot b or a times b. Yeah, a times b. So this one is a product. This whole signal, okay, is a product of a and b, because ab can be given as a dot b, which means it's a product of a and b. A and b. Similarly, here a bar b bar is a product of a bar and b bar. Okay, so here these products are added, or they have been used, they have been combined using an OR gate as given here by using a plus symbol. So this is what we call sum of products. You have the signals, okay, you have the products of signals, and you have summed them up to find the output expression. Okay, so that's what we call the sum of products form of a given expression. Okay, sum of products form of a given expression. You can even build on this. There can be more than two signals, right? Input signals. For example, let's say we have Q is equals to A, B, C bar plus A, B, C plus A, B bar, C. Okay, so this is a product, this is a product, this is a product, and here we have everything together as a sum of products. Okay, everything together as sum of products. These three products have been summed up by using two OR gates. Okay, so we can use multiple OR gates, we can use multiple AND gates, but the expression is given as a sum of products. For example, let's say we have with four inputs, let's say we have z is equals to a b c plus a bar b bar c d plus b c d bar. Okay, so if you look closely here, okay, if you look closely here, here also we have the sum of products form. This is a product, this is a product of four signals, this is a product of three signals, and here we have everything summed up by using two OR gates. Okay, so this is the sum of products form. Okay, one of the standard forms, the sum of product form. Okay, so this is cool. Yeah, this is cool. So there are some things you have to keep in mind. Okay, when you're writing sum of products, you have to be mindful that you can't have the bar sign. Okay, you can't have the bar sign over two signals. Okay, you can't have a bar sign over two signals or more. Okay, you can have over one signal, it's fine, but you can't have over two or more signals. What am I trying to say here? Yeah, what am I trying to say? So let's say we have something like Q is equals to a b bar plus a b whole thing bar. Okay, well, if you look at this clearly, this looks like actually sum of products. Okay, because here we have product of two signals, here we have product of two signals and then whole thing bar, and then we have summed up them by using a plus sign, an OR gate. Yeah, this looks like a correct one, but it is not, because in SOP form expression, a single O bar cannot be extended over more than a variable. Okay, we can't have it more than one single signal. Okay, so this is not in the product form. Okay, this is not in the product form. Okay, but you can have a bar b bar, a bar dot b bar is allowed, but a b whole thing bar is not allowed. Okay, this is okay, this is not allowed. So what you have to do is you have to break this down. So what will you get? Here we have a bar b bar plus, if you break this down, what will you get? You will get a bar plus b bar. Okay, Well, this is allowed. Okay, this is fine. This is sum of product expression. Why? Here you have a product. This is a single expression, but still a product. Yeah, this is a single term. Okay, it's still a signal, and this is also a product. So you have sum of product. Q is equals to a b bar plus a bar plus b bar. You can't say this is in SOP. This is in SOP. Okay, this is not in SOP. This is not in SOP. Okay, this is in SOP. Okay, so this is very important. Okay, don't make this mistake when you are writing the expressions in sum of products form. Okay, so let's say something is given like f is equals to a b c plus a b c, where bc is given as a whole thing bar. So a bc whole thing bar. Okay, and then let's say we have a b whole thing bar into c. Well, this is not in SOP. This is not in sum of products form. Okay, this is not in sum of products form. So what should we do here? We should first of all expand this. So what will you get? F is equals to ABC plus A into B bar plus C bar plus C into A bar plus B bar. And if you expand this all, you'll get ABC plus AB bar plus AC bar plus A bar C plus B bar C. Don't think about simplification at this point. Okay, don't think about simplification at this point. This is the sum of products form. Okay, they're asking you to write this down in SOP form. So you're just writing it down in SOP form. That's all. That's all you have to keep in mind. Okay, let's say we have something like Q is equals to let's say we have Q is equals to A, B, C, D plus A, B, C, D, where B, C, D is given as whole thing bar, plus A, B, C, D, where B, C is given as whole thing bar, plus A, D whole thing bar. How can you convert this to SOP? Because this is not in SOP. You can clearly see that. Okay, so you can expand this. So Q will be equals to A, B, C, D. Well, that is in product. That is nothing to, we have nothing to do with that. A, B, C, D whole thing bar. So you have to break this down. How can you break this down? Well, it's simple. You just have to break this down as B bar plus C bar plus D bar. Okay, so you would think like, how is it possible? Well, this is wrong, right? I mean, how we know how to break two variables. If you have A, B whole thing bar, we can say that is equals to A bar plus B bar. Yeah, but how can you say BCD, yeah, BCD whole thing bar is equals to B bar plus C bar plus D bar? How will it work? Well, let's break this down like we did here. Okay, so let's say BC is a one term. Okay, D is another term. So this will be equals to BC whole thing bar plus D bar. Yeah, you don't have any problems with that. Why? We are treating BC as a single signals and D as another signals like A and B. Okay, then we can break down BC whole thing bar. That will give us B bar plus C bar plus D bar. Okay, so that's why I have written it down directly. You can write it down directly because this is De Morgan's law. There is nothing wrong with that. Similarly, here we will get here we will get AD into B bar plus C bar, and here we have A bar plus D bar. Okay, here we have A bar plus D bar. So this will be equals to ABCD plus AB bar plus AC bar plus AD bar plus here we have AB bar D plus AC bar D plus A bar plus D bar. Now this is in SOP format. Okay, this is not in SOP. This is not in SOP. This is also not in SOP. Why? Here we have the sum. Okay, we have the sum inside a product. Okay, we have the sum inside a product. We'll learn about this in the POS video. I'll teach you. And here also, this is also not in SOP format. But this is on SOP format. This is on SOP format. Okay, so this is the basic thing you have to keep in mind.
Thanks for watching the 12th video in our Logic Gate series.
If you found this introduction to SOP and the techniques for converting expressions into SOP form helpful, don't forget to like, share and subscribe for more lessons. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master logic gates. Follow us on Instagram. I will see you in the next video. Until then, keep learning and stay curious. Bye bye.